My name is Sachin Kumar. I am a student of MTech in Physics Department in IIT Roorkee. So this PPT is to be submitted to Dr. Mayank Goswami and he is teaching us numerical analysis and computational physics in this semester. So my PPT topic is the Lagrange interpolation and here we will see quick note on Lagrange interpolation using MATLAB code or without MATLAB code. So outline of this PPT is we will see interpolation. After that we will see Lagrange interpolation and formulation. After that we will solve a problem on using Lagrange method, and after that we will see the MATLAB code of Lagrange interpolation of this problem, and after that we will see the direct code, or we can say MATLAB solver syntax command for this code. So in this slide, we will see what is interpolation. So interpolation is a mathematical technique to estimate the value of unknown data points that fall in between existing known data points. Or we can also say that to estimate the value of a point between two given point in a data set. Okay. So also it is a method of finding new data points within the range of a discrete set of known data points, or to find the value of y at any other value of x is called interpolation. So if we want to find the value of y here between the value of x0 and y0, or we can say by x1 or between x2, so this is the this is called as interpolation. So as we know that many times data is given only at discrete data points such as x0, y0, x1, y1, x2, y2, and x3 and y3. And if we want to find the value of fx here, or we can say the value of other data points here, so this is called the interpolation. Now in this slide we will see Lagrange interpolation and formulation. So this method is based on creating a polynomial of degree n. The degree depends on the number of points considered in the data set. So they should be n plus points, and so the basic form of the polynomial is yx is equal to y1 l1x, y2 l2x, and so on. Or also we can say it is a method of finding the value of any function at a given data points where the function is not given. So we use other data points on the function to get the value of the function at any required data points. So suppose we have a function y is equal to fx in which we want to find the value of y at x, and we have 2 points y1 x1 y1 x2 y2 on the curve. So the value of y at x will be calculated using the Lagrange interpolation method, and the basic form of the polynomial of Lagrange interpolation will be y1 l1 y2 l2 and so on. So here what is l1, what is y1, we will see in the next slide. So in this slide we will see that how we can find the Lagrange polynomial. So this is the general form of Lagrange polynomial, that is goes j is equal to 1 to n plus 1, and here j is not equal to I. So if you want to find the L1 value, L2 value, so you just need to focus on this formula. So x minus x2, x minus x3, x minus x4. So in L1, in the numerator part, you just need to skip one part, that is x minus x1. In the case of L2, you just need to skip x minus x2 part, and in the denominator term, you just need to uh, skip the part x minus x1, and you can go with the x1 minus x2, x1 minus x3, x1 minus x4, and similarly in this L2. So you can remember how to find the L1 L2 in this way. So this is the general form of Lagrange interpolation. Here, if you want to find the value of y at a x, so you just need to use this formulation where it goes I is equal to 1 to n plus 1. So, so now we will solve a question. So if we want to find the value of y at x is equal to 3, so we will use a Lagrange interpolation method. So the step regarding the solution, we just need to compute the value of L0, L1, L2, L3, and L0, L1, L2, L3. These are the steps we need to find, and after that we just need to multiply by 0, by 1, by 3, so on. So the value given value of x is 2, 4, 6, 8, and the y value is 10, 20, 30, 40, and the number of data points is 4. So as we know that the L0 is equal to x minus x1, x minus x2, x minus x3. As in the last slide we discussed about that if you want to find the value of x0, you just need to skip the x0 term to subtracting from the x, and you just need to in the denominator part you just need to subtract the other value from the x0 term, and similarly you can find the L1 term, that is L x minus x0, x minus x2, x minus x3, and as we discussed, you just need to skip the term to subtracting x minus x1, and here x minus x2, here x minus x3, and in the denominator part x1 minus x0, you just need to x1 term need to skip, and here you just need to h2 x2 minus x2 term you just need to skip, and after that you just need to use the L0, y0, L1, y1, L2, y2, and L3. You just need to put the these value of y0, y1, and y2, y3 from the data point, that is 10, 20, 30, 40, and you just need to multiply L0, L1, L2, L3, and you will get the answer is 15. So now we will see the Lagrange interpolation MATLAB code. Now in this slide we will see the MATLAB code for Lagrange interpolation method, and so here we use three commands, that is CLC, clear all, close all. These commands we use generally to clear the command window, to clear the uh, workspace, and to clear the all figures. So we initialize n and xp. Xp is the uh, is the interpolated point where we want to find the value of y. So n is equal to number of data points, that is we take 4, and we take these all data points from the last question we discussed in the last slide, that is the value of x is 2, 4, 6, and 8, and the y value is 10, 20, 30, 40, and we want to find the value of y at x is equal to 3. So x is equal to 3 means interpolated point xp is equal to 3. We initially initialize array to store the data points of x and y from the table. So we initialize x is equal to 0s 1 to n, and y is equal to 0s 1 to n. Now we are taking a for loop to display these data point from x1 to x4. So similarly we initialize by data points. So we can see x data point is 2, 4, 6, 8, and y data points is 10, 20, 30, and 14. And now we initialize a variable yp 0, and it will use to store the interpolated value of yp by so y, that is x is equal to 3. So now we want to find the Lagrangian polynomial, or we can say Lagrange interpolation. So we are taking here again I is equal to 1 to n for loop, and l we initialize l is equal to 1, and for we are also taking j is equal to 1, that is goes to n, and we take a condition give a condition that I cannot be equal to j. That also we see in the last slide that we cannot take I is equal to j, or we cannot take x1 minus x1 or y1 minus y1. So that's why, so it is the interpolated point x, and it is xj, and it is xi minus xj. So we cannot take xi or xi to for this loop. So if we want to display the L value, so we need to use this command, and it will display the L values L1, L2, L3 and 4. Now we want to find the value of Yp. That is Yp, initialize value of Yp plus L plus Li. So as we discussed in the last slide that y of x is equal to Li or Yi. So we just need to find the value of Wi-Fi here, and after that we just need to display this interpolated value, that is 15 at xp is equal to 15. And in the previous slide of the question we see the same result, and we can also see this result, or we can verify this result using the direct command. That is, we are taking x is equal to same data as in this problem as in the last slide problem, 2 4 6 8, and y is equal to 10 20 30 40. So we want to interpolate the value of y at x is equal to 3. So we just need to use the interfere p1 x comma y comma xp comma splen. So the answer is 15. So we can see the answer is same by the using the direct syntax command, or by using the MATLAB code, or by using the Lagrange method. So these are the references we use in this PPT. Thank you.